All right, welcome back, everybody. So you're here for part two in our three-part series. And if you do not know how an engine runs, boy, are you in for a treat today. I still remember when I first realized or discovered how the engine actually operates and works inside and what it takes to make it run. And it was just like, I was amazed by it. And the very first thing I did is I wanted to go tell people, whoever would listen to me, about how it works and explain it to them. And if you're like me, it's a big deal. Other people are like, who cares, man? I just turn the key and my car goes down the road, right? No, I need to know how it works. So if you're like me, you'll appreciate this. And a little bit about that is that a little bit about myself. Once I opened my business, I really found myself teaching, especially my employees. I was teaching them, and I found that I really enjoy doing that. So part of the reason why I'm here, why I'm doing this, and I hope you guys enjoy it. But anyway, today we're just going to go over exactly how the internal combustion engine works and what it takes to make it tick. So here we go. Hope you enjoy it. Here we have it, guys. The infamous internal combustion engine. This is what it's all about. So this is what propels your vehicle down the road. Pretty amazing how it works and how it's put together. And I know what you're thinking. This thing looks pretty intimidating, doesn't it? This is a big engine. It's got a lot of components, a lot of moving parts on it, but we're going to break it down and we're actually going to make it really simple for you. And I'm going to start by telling you the secret to making an engine run. Now, what if I told you that it only takes three things to make any engine run? So any engine you can think of, it only takes three things to make it run. Sounds kind of crazy, but here we have it. Fuel, spark, and compression. Those three things make an engine tick. So if you narrow it right down, that doesn't sound too bad, does it? Fuel, spark, and compression. That's doable. So let's dive right in and take a look. The four-stroke engine. So what does four-stroke engine mean? Basically, they call a four-stroke engine just that. This engine takes four strokes of the piston to create one power stroke, or to complete one cycle. So looking at these four strokes of the engine, we first have our intake stroke. The piston's coming down. It's going to be pulling in the air-fuel mixture with it. Our second stroke is compression. The piston is coming up, compressing the air-fuel mixture. Third stroke we have is the power stroke. That is when the spark plug fires and ignites the air-fuel mixture. And then finally, the exhaust stroke. The piston comes down after the power stroke, starts coming back up, and it exhausts all of that spent gases in the exhaust stroke. So to be clear, the spark plug fires every other time the piston comes to the top of the cylinder. Now, I just wanted to mention to you guys a little bit about the two-stroke engine. The two-stroke engine's not going to be something that you guys are really going to see. It doesn't, you'll never see this engine in a car, but knowledge is power. I just wanted you guys to know what sets a two-stroke engine apart from a four-stroke. Two-stroke engines are sort of becoming a thing of the past. You'll see them still in dirt bikes, that type of stuff, but weed whippers, all that little stuff. The reason you'll never see them in a car is because they never found a way to make a two-stroke engine run as efficiently or as clean as a four-stroke engine. And for that reason is why you'll never see them in a car. But anyways, it's pretty cool how they work, so I wanted to show you. The two-stroke engine fires the cylinder every two strokes of the piston, hence the two-stroke name. the two-stroke engine requires oil to be mixed with the fuel. So it does not have a crankcase full of oil. The oil actually gets mixed in with the gasoline or with the fuel. So totally different. And I'm going to show you how it works. Okay, basically, if we go to this first picture here, imagine the piston has a charge of air and fuel already in it. We're going to explain that in just a minute. So it's coming up. It's going to get to its peak or top dead center right here. The spark plug is going to fire. Now the piston travels down. So I'm going to hop right over here. Piston travels down, exposing this port right here, the exhaust port. The exhaust gases rush out of it. As that happens, the piston keeps traveling down and opens up this port. That's a transfer port. The downward motion of the piston creates a positive pressure down here in the crankcase, causing the air-fuel mixture that sits in the crankcase to come up through the transfer port on top of the piston. As the piston goes up, compressing the fuel, it now opens the intake port. So imagine a carburetor or something sitting right here. That's an intake port. So totally different how it works. It takes the air-fuel mixture, brings it into the crankcase before finally bringing it on top of the piston. And it's a totally different way to make an engine run, but it works. So we're going to hop back over to the four-stroke engine now. We're not going to talk anymore about the two-stroke engine, but we are going to talk about the engine components, all the different pieces of the engine. So let's start out with the crankshaft. The crankshaft is kind of the heart of the engine, or the backbone, if you will, of the engine. The crankshaft's job is going to be changes reciprocating motion into rotary motion. So a piston that travels straight up and down vertically, by the use of a crankshaft, we take that vertical motion and we turn it into a reciprocating motion. The crankshaft also counters the motion of the reciprocating parts. It balances it. It basically has the weights on the bottom of it to smooth out an engine that's going to be running. Without those weights, it's going to just be a vibrator, and the thing's just going to basically rattle itself apart. So another job that the crankshaft has is it adds momentum. It adds momentum to the engine, helps everything keep spinning in the right direction, and keeps it from stalling out. One other thing it does is it allows oil to flow through it. You see all those little holes in the crankshaft? Those are oil holes. So it allows oil to flow through it to lubricate the rod and main bearings. You can see all those little holes lubricate a bearing. So the whole inside of that crankshaft is hollow, and the oil travels through the entire thing. So that's kind of neat. Moving on to camshafts. Now a camshaft's job is it opens and closes the valves using lobes, or those the raised portion that you'll see on the ramps that you'll see on the camshafts. Camshafts always spin half the speed of a crankshaft. So for every full revolution, for every full rotation of the crankshaft, the camshaft only spins half of that. It's the way it's designed to work, and we're going to get into that a little bit. We're going to get into that a little bit closer, but moving on to pistons. So pistons, machined out of aluminum. Pistons are the heart of the engine. This is what's really doing all the work, moving up and down and taking the pressure from the ignition and turning it into a force or into a motion. Some kind of interesting information here. The peak pressure in your combustion chamber. So when that spark plug fires your air-fuel mixture, you're actually going to get 1,000 psi of pressure inside that combustion chamber. Peak temperature inside the combustion chamber, 4,000 degrees Fahrenheit. So there's some serious amount of pressure and heat inside that combustion chamber. So your pistons really put up with a lot of abuse. And they're always aluminum. and you'll see the little rings right here. Those 3 rings right there, those are the piston rings. So we're going to hop into talking about the piston rings here. What is the purpose of the piston rings? Purpose is to seal combustion gases and to control cylinder oiling. So typically there's going to be 3 piston rings on every piston. Starting with the topmost ring, the compression ring. The compression ring does most of the sealing. The second or middle ring is a scraper ring. It helps with the sealing and oil control. And finally, the third ring, or the bottommost ring, is the oil control ring. It regulates the amount of oil in the cylinder. What that means is oil sticks to the side of the cylinder wall. Every time the piston goes up, engine oil sprays at basically at the bottom of the piston or at the cylinder walls. And if those pistons rings aren't working properly, piston's going to come down and it almost acts as a squeegee. It cleans the oil off of the cylinder wall, because we do not want that oil to go on top of the piston, past the piston rings, on top of the piston, because the oil will get burned. It'll get burned off, and you'll start burning oil. You start blowing blue smoke, and that's one of the signs of a worn piston rings. If you're consuming oil and if you're blowing blue smoke, we're going to talk about all that later. So anyway, piston rings are very important. It takes the oil away from the cylinder, puts it back down in the crankcase. Piston rings must have an air gap to allow for heat expansion, also known as ring end gap. So when your piston ring's installed on the piston and the piston's installed in the cylinder, your piston rings right here, you're going to see, now when they're installed, that gap's going to be far smaller, but you're never ever going to have the piston ring end gaps touch. There's always going to be a small gap there to give adequate room for heat expansion. If those rings touch, bad things are going to happen. The rings are going to bind and it's going to tear stuff up. Here's a little tech tip for you. Always install piston rings with the marks facing upward. And what I mean by that is, if you look real closely, sometimes on the very top of the piston ring, it's going to have some part numbers, some letters, whatever. It's going to have some sort of a marks for you. Those marks always need to face upward. So make a note of that. Connecting rods. So connecting rods join the piston to the crankshaft. We talked about the crankshaft, we talked about the piston. The connecting rods are what connects the 2 things together. Rod bearings. That's going to be these things on the far left here. That's your connecting rod bearings. And that's going to be where the connecting rod bolts or attaches to the crankshaft. Rod bearings also need an air gap. On the far right hand, the picture I have for you right here shows the gap, and how that works is it's called a plastic gauge. So you take a little piece of plastic, you take your connecting rod with your bearings, and I should start by saying your bearings actually sit right here inside your connecting rod. Now you take your connecting rod, you bolt it onto your crankshaft with a little piece of plastic called plastic gauge, and you torque it down, and the amount of basically width that it squeezes that plastic, it's going to squish that plastic, use that plastic gauge, and it's going to tell you how big of an air gap. That's how you measure that. Stuff you don't need to know right off the bat, but it's just good to know. So it needs an air gap so you can get oil in there and enough room for heat expansion as well. Measure air gap using the plastic gauge, which we just talked about. Okay, so we're going to move on to the crankcase and the oil pump. Crankcase refers to basically the engine block, whatever houses all the components, whatever houses the crankshaft and pistons. Your oil pump, seen here on the left, they're typically chain driven, and it's just the oil baffle, or the oil pickup tube, I should say, sits down in the oil pan. It sucks oil up, and it basically just feeds the entire engine with oil pressure. Pretty important part, as you can imagine. Cylinder head. So the cylinder head allows air and fuel to enter the combustion chamber and exhaust to exit. Houses the valves, the intake and the exhaust valves. You can see right here. Also houses the spark plugs, cooled with engine coolant. Every cylinder head you're going to run into has coolant running through it, and it goes right through the cylinder head through different coolant passages, keeps it cool. It also helps it warm up on a cold engine. Tech tip: whenever replacing head gaskets, it's a good idea to have the head pressure tested and resurfaced at a machine shop. Most likely the shop you're working at is not going to be able to do those things. So what we do, in our shop, whenever we have a cylinder head off for whatever reason, usually it's to replace head gaskets, just to err on the side of precaution, we usually take the cylinder heads, bring them to the machine shop. They're going to do a couple tests on them, a pressure test, a vac test, tests all the valves, and it also checks for any sort of hairline cracks in the cylinder head. And then they also resurface the gasket surface, the mating surface. They clean it up, flatten it out. So that's always a good idea when you have heads off. It's not real expensive, and it's going to save you, a possible comeback. So we'll talk about the valves here. The valves seal the combustion chamber when closed, and when open, allow air movement through the intake or exhaust passage. So very important for such a small part. They just acted as a one-way valve. They last a long time. Oil pan. Pretty straightforward. That's what your oil pan looks like. Sometimes it has an actual gasket, sometimes it's silicone down right here. It just holds the oil. Your oil pickup tube sits in it. Valve covers, they're gonna bolt on top of your cylinder heads, and that's gonna be, they're protecting and keeping the oil in there. So now we're talking about main seals. Main seals, you're typically going to refer to them as rear main seals, front main seals, but the main seals, the seal that seals the crankshaft to the engine block. You can see in the picture there that round, big round seal right here. That's going to be your main seal. The rear main engine oil seal is always the inward most seal between the engine and the transmission. So when you hear somebody say rear main seal, what does that mean? That means rear main, so that means the seal that goes between the engine and the transmission. A front main seal, when you hear somebody say front main seal, that's going to be the outermost crankshaft seal. So that's going to be the seal up in front of the engine, the seal that's the most easy to get to. Usually sits right, well, it's going to sit right behind the harmonic balancer, which we're going to get to. That's going to be the most easy of the two seals to get to. The rear main seal, you always have to remove the transmission to access it. So if you have a rear main seal leaking, a lot of times it's a pretty big job just to change it. One thing to always keep in mind is if you have the transmission out of a vehicle for whatever reason, better take a look at that rear main seal. Some guys probably replace them every time they take a transmission down. What I do, if I have the transmission down, I'll take a look at it. If it looks at all wet or if it's starting to seep, I recommend replacement of it. If it's dry, if it's bone dry, I usually leave it alone. Okay, this is a really cool video that I found. We got to give credit to Paramount AutoZone for this video, but it's an animation showing basically how an engine is assembled, all the different components, and how they all work together. So I'm going to play this and kind of explain to you as we watch it what you're seeing. Okay, so I know the picture's just a little bit fuzzy there, but so there's your crankcase, your engine block. There's your crankshaft that we learned about earlier. Now there's our connecting rods and our connecting rod bearings. Our pistons are coming on there with the piston pins. Now that assembly is going into the engine block, getting bolted in. There's your rear main seal, your flywheel or flex plate. That should look familiar. There's your cylinder head. Here comes all the valves, springs, retainers. There's our buckets. And you can see this is a dual overhead cam engine. So there's our camshafts, head gasket. Now the cylinder head's being placed on the engine block. Okay, we got a gear there. Our oil pump is being installed. Oil pump chain. There's our timing chain, our guides, and our hydraulic tensioner, followed by the timing cover. There's our valve cover. Man, this video is cool, isn't it? All right, there's our oil pan. Oil level sensor right there, which not all engines have. That's our oil filter housing being put on. There's our thermostat housing, our starter, the PCV system or oil separator, knock sensor. Not exactly sure, just some more components. Okay, there's an oil or a coolant crossover pipe. There's your intake, engine oil dipstick, fuel injectors, wire harness, spark plug wires and ignition coil are there. Okay, there's your water pump. Water pump pulley, an idler pulley. That's a crankshaft position sensor and your harmonic balancer. Your AC compressor there, air conditioning compressor, a power steering pump. That's an idler pulley, no, and that's the tensioner actually. The alternator, this is a little coolant pipe, your serpentine belt. There goes the exhaust manifold and a heat shield. And that's it. So now you can see the inner workings of this engine. As the pistons go up and down, the valves are opening and closing. You can see the outer pistons and the inner pistons move opposite of each other. Okay, now it's going to show you the actual strokes of the engine. So you can see the blue represents the air fuel mixture that comes in there. So there it comes in, the spark plug fires it, the exhaust exits. So the exhaust is actually the redder gases. So intake, power, exhaust. Intake, compression, power, exhaust. So there's our 4 strokes. Power, exhaust, intake, compression, power, and exhaust. So that shows you exactly what's happening inside that engine. So you can watch that piston just moving up and down. I thought this video was so cool. I know some of you are having an epiphany right now, just been like, oh, that's how it works. I've always wanted to know. All right, so there you have it. Hope you enjoyed that video. So a couple last things before we wrap up here. we're going to talk about diesel engines. So what makes a diesel engine different from a gasoline engine? The biggest difference is the lack of spark. So there's no spark plugs in the diesel engine. Instead, they use these things down here called glow plugs. Gotta get my laser pointer there. Glow plugs. Diesels use direct injection, which means fuel is injected directly into the cylinder. One last note, most of today's diesel engines are turbocharged. So how does this engine run without a spark plug? Well, it works the same exact way as a gasoline engine as far as the pistons and the valves, you know, the four strokes. But the air fuel it brings in, diesel fuel obviously is more of an oil than a gas than gasoline. But when the piston compresses the air fuel mixture, diesel engine uses a lot higher compression rate than gasoline engines. So as that air fuel is getting compressed, it's actually heating up. It actually gets really hot just by the compression. In fact, you can really run a diesel if you wanted to without a glow plug, just because the piston brings that air fuel ratio to such a high compression that the heat generated by the compression is actually what fires the mixture. However, they use a glow plug right here, and that end of that glow plug just gets red hot, and so that aids in the ignition. As soon as that piston comes up with the air fuel mixture, it gets to a point where there's so much compression that it ignites, and it starts with igniting. It starts right by the tip of that glow plug. The glow plugs also are really important for getting an engine to start when it's cold, a diesel engine to start when it's cold. So that's what makes the exhaust, or that's what makes the diesel engine so much different. And finally, we're going to talk about engine oil before we wrap up today. Engine oil is the lifeblood of the engine. It's very, very important. It's got 4 jobs, believe it or not: clean, cool, seal, and lubricate. So let's think about that. There's detergents in engine oil, just like you have in your, in your laundry room. There's detergents that help clean the engine. As the oil passes over parts, it actually cleans it. It cleans some of the carbon and some of the gunk, the debris off it. Cool. Engine oil actually cools parts as it passes through as well. Some engines use an engine oil cooler. Usually, most don't, but the engine oil just rotating through the engine, it does cool it down. The engine relies on that cooling, and engine oil actually helps seal, which sounds kind of odd, but your piston rings that we talked about earlier would not seal near as well without oil. If you do, there's actually a compression test. You can do a wet versus a dry compression test, and you'll be amazed at how much a little oil helps those piston rings seal. So the engine relies on that to seal. The piston rings relies on the oil. Finally, lubricate. And when I say lubricate, it actually keeps the moving parts from contacting each other on a micro scale. If you take your 2 pieces of metal, put them next to each other and rub them on each other without any engine oil, you can feel them scraping. You can feel metal on metal contact. If you take a little oil, say you get 2 pieces of tin, you now set the 2 together and you rub it together, you feel far less friction. It's actually, the small oil molecules are actually keeping those metal parts from contacting each other. So that's how come your engine will run for, that's why you can get an engine to run for 200,000 miles without, completely just wearing itself apart. So let's talk about the difference between conventional and synthetic oils. So conventional oil comes out of the ground. It gets pumped out of the ground, and then it goes through a process of being cleaned and refined. whereas synthetic oils are made in a laboratory. They're actually made, they're man-made versus, fossil fuels that come out of the ground. Recycled oils, I have nothing really good to say about recycled oils. Guys, if it were me, I would just steer clear. I would not be the one to want to be responsible for somebody's engine failing and said, yeah, but you told me these recycled oils was good. Well, I would just steer clear. They're sometimes they're a little bit cheaper, but think about, I had a instructor of mine tell me once, he said, imagine you went to the doctor and you needed a blood transfusion, and he said, the doctor says to you, we have this really good blood over here. It's very expensive, but if you want to save some money, we have this blood over here. It's a lot cheaper. It's not as good, but it'll work. It's just kind of puts it in perspective. Obviously, you're going to say, I want the better blood. So same thing for your engine. You don't want to cheap out when it comes to oil, and you want to change it on time because sludge is the biggest problem with not changing your engine oil on time. As you start working on vehicles, you'll open up an engine and you'll be able to tell if the engine's had good oil changes or not such regularly done oil changes by looking at the amount of sludge inside of it. So back up here, myth. Once you go to synthetic, you cannot go back. Not true. Everybody has different theories about that. Oh, it conditions the rubber. Excuse me. Conditions the rubber, the seals will always leak, and oh, my engine's knocked before when I've used synthetic. That's not true. I wouldn't recommend switching back and forth on a regular basis, but it's definitely not the case. Synthetic oils, they all work the same way. You're not affecting anything by switching, one way or the other. So, okay, we talked about this. What happens if you don't change your oil? Sludge buildup can also be thought of as a blood clot. There's tiny orifices that go through your engine. So all that sludge, just like a blood clot, builds up over time until the oil doesn't come through there like it should. And then that's when we end up with oil starvation and parts that wear out. And it does happen. Yes, it does happen. You'll open up engines and see there's nothing but sludge inside there. And a lot of times that's the cause of the failure. So engine oil viscosity. When you look at numbers like 10W30, 10W40, those numbers reflect viscosity. Viscosity equals the flowability of the oil at a particular temperature. The higher the numbers, the thicker the oil. Think of gear lube. Gear lube is 80-90. There's different weights, but gear lube's typically 80-90, very, very thick oil. An engine oil, the lowest I know of right now is 0W20, and that's very, very thin oil. So viscosity is the flowability at a particular temperature. So here's a little something to go away with to impress your friends. What does the W stand for in 10W30? And guess what? It does not stand for weight. The W stands for winter. It means it's a winter blend oil. So 10W30 means winter blend oil. Now think of that. Have you ever heard of just a straight 30 weight? Yeah, they're out there. What do you use a straight 30 weight oil in? A lot of times I've only seen it for like lawnmowers and stuff like that, stuff that doesn't need to be driven in the winter. So the W means that it's a winter blend oil and that it's meant to withstand cold weather operation. So that pretty much wraps it up for now. I hope you guys enjoyed that, and now that I hope engines make a little bit more sense to you. All right, so I hope you guys learned something there. We are starting at the basics a little bit here, but believe me guys, I know auto repair can seem very overwhelming and intimidating, but if you boil it down and it's explained to you in the right fashion, it's really not that bad, I promise. That being said, keep your eyes open on your inbox because the The third part of the series is on electrical. And that's something that scares a lot of guys away. But stick with me. I want you to watch this, and I guarantee you I'm going to explain it in a way that nobody's ever explained it to you before. And it might just click with you like it did with me. So check it out, and we'll talk to you soon.